Okay, we don't have a whole lot of examples to go through today, so this should be a fairly quick video unless I get kind of chatty. So let's cross our fingers that doesn't happen. So I hope that you can notice that all of these equations have perfect squares somewhere involved in them. In order for this new strategy to work, you're going to have to be able to recognize your perfect squares. So recognizing that 16 is the perfect square, 49 is the perfect square of 7, 100 is the perfect square of 10. Don't forget about 1 being a perfect square, 9 is a perfect square, 36, 81, 4. If you don't recognize them, then this strategy is not really going to work out for you. So we're going to be using this strategy on equations that look like this, set A. A new strategy we'll learn tomorrow, well, in your next set of video notes, will be equations that look like set B. So today we're focused on just things that have a squared term and a constant term. We don't have any x's, single x's, just x squared terms and constant terms. So as a quick reminder, we can solve in the things that we've already known how to solve is by graphing and by factoring. So if I graph this equation p squared equals 16, then I graph the equation p squared, I look for where the function equals 16, and that would be at -4 and 4, so those would be your solutions. If I factor it, I have to set it equal to 0, and then this is a perfect square, and so my factors would be p minus 4 and p plus 4. Remember to take the square root of each one. One of your parentheses is positive and one is negative. And then when you set each factor equal to 0, then p equals 4 and p equals -4. So a new way that we can solve it is, remember anything that you do to one side of the equation and you do it to the other side of the equation, then it's still equivalent. Like if I add 5 to both sides, I just added 5 to both sides, but they're still equal. Or if I multiply one side by 2, then I have to multiply the other side by 2, and they're still equal. Well, if I take the square root of one side, I take the square root of the other side, then they're still equal. So the square root of p squared and the square root of 16, take the square root of p squared and I get p. The square root of 16 is positive or -4. This is a new symbol that you might not recognize. Remember that if I take 4 times 4, oop, it's being glitchy. Stop it. My apologies to you. 4 times 4 is 16, or -4 times -4 is 16. So whenever we take the square root of a number, the square root of 16 is not just 4, it's either +4 or -4. And so that plus minus sign, that's what that means. It's going to be very important not to forget that it could be positive or negative. So like I was saying, 4 times 4 or -4 times -4. It just doesn't like me today. Okay, so that's what this symbol means. And remember when we found our solutions earlier, it was at, on the graph, it was at +4 and -4. And then when we factored it, we got x equals 4 and x equals -4. And so this is all just tying all that together. I was trying to show you the other page. Here we go. -4, 4, -4, 4, it's -4, 4. Okay, moving on. You do not have these examples, so you're just going to be watching. I take the square root of this side and the square root of this side. I get n equals positive or -10. And then I do the same thing for the 7. Just because it's not a perfect square doesn't mean you can't do it. And in which case we will be rounding to the nearest 100th. So if I take the square root of each side, I have t equals 2.65. So you can round to the nearest hundredth. Or we could even say this is plus or minus the square root of 7. That's another way you might see it. So it might be just left as the square root rather than as a decimal. So using those two as examples, you're going to do those two. We're going to look at them when you get back to class on Monday. These are just a little bit different. So I want the x squared term by itself in order to make this work out. So to get this x squared by itself, I have to subtract 8 from both sides. So I would have x squared equals 10, and then do my square roots. And the square root of 10 is 3.16. So x equals positive or negative 3.16. So same over here. I would add 98 to both sides. So 2x squared equals 98. Divide both sides by 2 because I want x squared by itself. X squared equals 49. Take the square root of each side, and 49 is a perfect square, so x equals plus or minus 7. So using those as examples, you will do your next two. Just remember you're trying to isolate the x squared, so think about what you need to do, or in this case g squared, what you need to do to isolate that variable. These look a little bit different also. So in this case, this is showing me kind of what the factors already are. This would be 1 plus 1 times 1 plus 1, x minus 2 times x minus 2, x minus 3 times x minus 3. So what's easy about this is this whole thing is squared, so it's isolated already. Like, I only have one term being squared here. Just like if I say x squared, that's only one term being squared. So I can just take the square root of this and take the square root of this. So the square root of x plus 1 squared is just x plus 1. And then this equals plus or minus 4. Now in this case, what I would do is rewrite this as two separate problems. So x plus 1 could equal positive 4, and x plus 1 could equal negative 4. And then from here you solve for x. So I would subtract 1 from each side, which would be 3, and I subtract 1 from each side, which would be negative 5. Okay, we're going to do that again. So I take the square root of each side, and I have x minus 2 equals plus or minus the square root of 8. So I'm going to be working with the decimal now, 2.83. So I'm going to rewrite my two problems. I have x minus 2 could equal positive 2.83, or x minus 2 could equal negative 2.83. So if I add 2 to both sides, I would have x equals 4.83. Or add 2 to this, and I would have x equals negative 0.83. Okay. I've taken up a lot of space. We'll see what happens. Okay. This one, I need to isolate this part first. So all you're going to do is subtract 4 from both sides. So you have x minus 3 squared equals 36. And then same process. Square root of each. X minus 3 equals positive or negative 6. So I could have x minus 3 equals positive 6, in which case x would equal 9. Or x minus 3 equals negative 6, in which case x would equal negative 3. Okay, so using those as examples, you have these 3 to do. And then we have this little application thing. We're going to work with the formula area of a circle, so A equals pi r squared. And our problem says that the circular tabletop has an area of 12.56, so we plug that in here. This can be represented in the following equation. We're going to use 3.14 as pi, so then solve to find the length of the radius r. Well, if I want to isolate this, I need to just divide both sides by 3.14. So 1256 divided by 3.14 is 400. So 400 equals r squared. Take the square root of each side. R equals positive or negative 20. And then we have to think about, I have my two solutions as positive 20 or negative 20. I can't have a tabletop with a radius of negative 20. So it would be 20 inches as your final answer. So that's that bottom question. So one last thing before we're done here. Can you solve these equations using the square root method? Well, this equation, I can do, the problem is you can't take the square root of a negative, because the only way to equal a negative is a positive times a negative, and square roots means they have to be the same, so I need a positive times a positive or a negative times a negative, so I can't take the square root of a negative number. However, this, I could divide both sides by -1, and it would really just end up as, like I'm just taking this function, negative x squared, and finding where it equals -9, which would be at -3 and +3. However, if I look at this function, and I take negative x squared, that would be down here, and it doesn't cross y equals 9. So if I divide both of these sides by -1 to get this positive, then it makes this negative, and that's, I mean, it's not going to work out. So this one I can solve using the square root method because I divide both sides by -1 first. This one, no matter what happens, I'm going to have to do the square root of a negative, which doesn't work out. And it doesn't work out because there's not an intersection, so that's why it's not working. So tomorrow when you get, or Monday when you get to class, we'll be filling this in on our little booklet, so don't forget to bring that. And don't forget about your feedback.